So this problem says a couple has 3 children. Imagine if we started with question B that says find the probability that when a couple has 3 children they will have exactly 2 boys. Could you jump right into that problem? Well, no, because you don't know all the different ways that a couple could have 3 children. So before that, we have to go back to part A and find a sample space. Now, we're never going to ask you to do a huge one, but you might be asked to list out the possibilities. And some of you are good listers, and some of you are afraid you're going to forget something. So go back to your multiplication counting principle that we learned, and think about if we have 3 children, that's 3 events, and we're going to count boys and girls as equally likely. So there's 2 possibilities for the first event, 2 possibilities for the second event, 2 possibilities for the third event. 2 times 2 times 2 is 8. And the nice thing about that is that this sample space, this list that we're about to make, has to have 8 items in it. And so that way we'll know we'll have all the outcomes. Now, I usually try to think all the different ways that something can happen starting the same. So for instance, if I had a girl as the first child, I might have a girl as the second child and a girl as the third child, 3 girls in a row. Or I might start with a girl, have another girl, and then a boy. Or I might start with a girl, have a boy, and then another girl. Or I might start with a girl, have a boy, and another boy. And if you look through that, there's no other ways to have 3 children if you start with the girl. The other way you can think about this is if there's 8 possibilities, 4 of them are going to start with girls and 4 of them are going to start with boys. If you're good with the tree diagrams, that might help you as well. But now we can just go back and flip-flop these. Instead of 3 girls, we can have boy, boy, boy. Instead of girl, girl, boy, 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 girl. Instead of girl, boy, girl, boy, girl, boy. And instead of girl, boy, 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 girl, girl. And so we now have the 8 different outcomes of the possibilities of having 3 children. Again, this is the sample space. But now that we've done that, we can answer the question in part B. What's the probability that you're going to have exactly 2 boys? We know exactly means not 1, not 3, but only 2. So P, probability of 2 boys. And if we go back to our list up here, we can see on the left-hand side there's one option, girl, boy, boy. On the right-hand side we have 2 options, boy, boy, girl, and boy, girl, boy. Remember, we don't use the 3 boys because it has to be only 2 boys. So we ended up with 3 outcomes out of the 8 possibilities, and that would be the probability. Now, if we wanted to turn this into a decimal, 3 divided by 8 would give us 0.375. And that's important because part C says, is it unlikely for a couple to have exactly 2 boys when they have 3 children? So is that example in part B an unlikely example? And you'll need to remember the definition for unlikely is that it is less than 5% chance, less than 0.05. And since we already turned our fraction into the decimal, we can obviously see that 0.375 is not less than 0.05. Or you could write 0.375 is greater than 0.05. And so we're going to write that this is not unlikely. We actually never write that something is likely. We don't have a mathematical percentage for that, but we do write that it is unlikely if it's less than a 5% chance, or not unlikely if it's over a 5% chance.